Hello everyone, my name is Bogusz Pawłowski, and first and foremost I wanted to thank you all for having me here. This is actually a great pleasure, and this is actually my first time in Japan, and it was nothing but amazing for me, although if you ask me, it is a bit hot for me. So today I wanted to talk about error handling. So the title of the talk is Beyond Exceptions. Why is that? Why I chose that topic? So I actually work as a staff engineer at Spoton. And by the way, you can scan the QR code if you want to get the slides and the examples from this talk so you can follow along. So I work as a staff engineer at Spoton. And in Spoton, we are actually delivering very complex restaurant POS systems. So what it does mean is we actually deliver it only for the US market, and the restaurants have most of the time some kind of basements or some kind of garden when you can eat. So what it does mean is that we don't have the network connectivity, or at least we don't have good network connectivity there. So it means that we must deliver our software in offline first approach. I don't mean like offline first approach that we just cache some things for a few minutes or something like that. We actually can work for hours or even days without the network connectivity. And during that time, we actually run transactions, printing, orders, synchronizing, and so on. So there's a lot of going on there. So it means that most of the logic that normally would be on the backend side is actually on the client. So our Android applications have a very complex logic inside of them. There are also multiple applications that we are running in the same system. And we have some kind of local connectivity between them. We have the inter-process connectivity between them. So there's really a lot going on. And additionally, I wasn't aware of that before joining this company, but restaurants actually have a very complex and very big domain. So we have things like KDSs, transactions, printing, online ordering, end-of-day process, and so on, and so on, and so on. So it's actually very complex software. So it all means together that we have a very high potential for errors, because there are a lot of moving pieces. So naturally, the topic of error handling is of interest to me. And the second reason is that I love Kotlin, but there's always a but. To me, always the error handling in Kotlin feels kind of all over the place. So let's try to discuss why it is that way. So we'll start actually with a brief history of Kotlin error handling to understand why we are in that place. So of course, we have to start with Java. So talking about error handling in Java, usually we think about exceptions. But actually, we have two types of classes that are meant to handle the errors in Java. So we have errors and we have the exceptions. Both are actually inheriting from throwable. So throwable means just that you can throw this actual class. So if we take a look at those two classes, two different classes, error and exception, and we read about it in the Java documentation, we can see that the class exception and its subclasses are a form of throwable that indicates a condition that reasonable application might want to catch. On the other hand, an error is a subclass of throwable that indicates a serious problems that a reasonable application should not try to catch. So the errors represent some kind of systemic failure that we should not handle inside of our application, or at least locally. And exception is actually something that we can use for error modeling. And there's additionally in Java the concept of checked exceptions. So checked exceptions mean that we can actually declare our function using the keyword throws. We indicate to the compiler basically that this function might throw this exception. So this is pretty cool concept actually, because the compiler will then know about it and it will actually force us to handle that exception. However, there were some problems with it. So first of all, we, the developers, always the problem starts here. So we started to abuse those APIs. So there were a lot of functions in some libraries and so on that were declaring a lot of checked exceptions, but weren't actually throwing them at all. So it forced other developers to actually ignore that exception, so it kind of defeats the purpose. The second problem started with Java 1.8. So in that version of Java, we actually got some kind of functional programming going on, and functional programming doesn't mix well with checked exceptions. So those two reasons meant that when Kotlin was created, the creators of Kotlin decided to drop the checked exceptions completely. And this is actually true for all other JVM languages. And Kotlin creators actually said explicitly that in Kotlin, we shouldn't use the unchecked exceptions for local error handling. We also have the throws annotation, so it might look a bit like we do have checked exceptions, but actually it only impacts the Java code that is referenced in Kotlin. So for Kotlin, there's no such thing as a checked exception. So the fact that we don't have checked exceptions and only unchecked exceptions really begs two questions. So first of all, how are we supposed to model errors? This is the first one. And the second one is, what are the exceptions in Kotlin for? So to answer those two questions, we actually have to answer another question, which is, what actually are errors? So we'll try to go through some error definition. So we can actually split errors into two different categories. First of all, we have what I call domain errors. So these are really just unhappy scenarios. So for example, we can imagine that we perform some kind of HTTP call, and we get 200 response from error. This is a happy scenario that we want to get, but this is actually not what we always get. We can also get like a 400 error, or we can get an information that we don't actually have an internet connectivity. And those two scenarios aren't really something that is not expected or is a surprise to us, because that happens frequently. So those aren't really like a separate thing from the happy path. Those are just different types of flows than the happy path. And then there is the other error type. So this one I call program logic error. So this is actually means that we made some kind of mistake. So for example, we didn't anticipate that there might be a null variable in our code base, and we accessed it, and we got the null pointer exception. So let's try to compare those two. So for the domain errors, they're always anticipated because they are just different flavors of our main flow, of the happy flow. For the program logic errors, these are really just mistakes. So unfortunately, we cannot anticipate them, because if we were, we could actually handle them. Can they be handled gracefully? So as mentioned, domain errors are nothing less than just a different type of flow in our application than the happy path. So we should always handle them gracefully. For program logic errors, this is not that easy, because we cannot anticipate them. Usually it means that we cannot handle them gracefully. We can handle it, but it usually involves some kind of global error handler that is just, for example, restarting an application or something like that. So I wouldn't call it really graceful. And the last most important question, what Kotlin feature should we use to handle them? And this is the actual question that I would try to answer on that presentation. So let's start with domain errors. So I will use one example, very simple one, for trying to model domain errors, and we'll try to apply different error handling strategies, and we'll see which one is the best. So the example that I want to give you is that we have an application, and let's imagine that we have some kind of input form. And we are actually receiving a phone number from the user, but the phone number is in a form of raw string. So what we want to do actually is to have a type-safe system. So we want to convert that into a concrete class. I use value class for that, but data class would be fine as well. So the thing that we will be implementing is the conversion function. So the conversion from raw string to a phone number. For sake of simplicity, I just use an extension function. This could be a class or whatever, really. So let's try to implement that. First of all, we will break all the rules that we know from the Kotlin, and we'll try to use exceptions for that. So the implementation of this function could look a little bit like that. So we have just a regular function that checks if the provided string matches some kind of pattern that is representing a phone number. If it does, we just return a phone number. And if it doesn't, we actually throw illegal argument exception. So this looks pretty good at a first glance. This is reasonable to throw an exception in that case. But let's try to use it actually in some kind of code base. So we have some kind of invalid input and we pass it to this function. And it might seem okay, but actually during the runtime, we know that there will be a crash here. So why do we know that there will be a crash here? We only know about it because we saw the implementation details slide before. If you just would have the access to the signature of the function, there's nothing telling us about that. So what we should do is to wrap the piece of code in try-catch, but without the implementation details, we cannot do that actually because compiler won't tell us to do that. So until we see the implementation detail, we won't handle that properly. So this is the first problem with the exceptions. And the second one is that we actually are pointlessly creating an exception. When we create an exception, we actually collect the whole stack trace. And the stack trace is usually pretty good for debugging because it contains a lot of information. But for our case, we actually are handling the error locally. So we know exactly where it happened. So the stack trace is actually pretty useless. And collecting the stack trace is not the lightest things to do. So we are actually hurting our performance in some way. So if there are problems with using exceptions for that, what else can we use? So we can actually take a little bit of inspiration from the Kotlin standard library, and we can use nullability. So I'm sure that you actually saw that kind of function. So for example, we have a function to convert a string into an integer, and in standard library of Kotlin, we would actually have a variation of this function that would be called toInt or null, and it returns a nullable value. So we can apply that to our example. So the implementation could look a little bit like that. So we changed the name of the function, and we actually changed the return type because now we have the nullable's phone number. Other than that, the implementation is pretty much the same. We are checking if it matches the regex pattern. If it not, we actually don't return an exception, we just return a null. So in terms of using that in our code base, this would look like that. So already you can spot that it is a little bit better because we actually have the information that something might go south because we have that nullable type. So we actually, if we try to access that variable, the compiler will force us to handle that. So this is much better than the exception in terms of visibility. There is, however, one problem, or two. This still requires knowledge of the implementation details because how do we interpret the null value? We don't know what actually it means. If it means that the input was too short, or if it was just invalid, or if it was blank input. So this is a problem with using a null. And the second problem is that we are actually only limited to one possible error case. So you cannot express multiple different things with null because it's just a null. So if we wanted, for example, for this function to inform us if there was, let's say, blank input or the number was actually invalid, we cannot do that with nullability. So what we are really looking for is to be able to return two different value types from one function. So nullability, I would say, is a good way to handle that, but only for the really simple cases. Like, for example, you saw in the standard library, we have the conversion from the string to an integer. That's a very good way of using that. But if we want to have some kind of more complex error handling, what can we use? So in Kotlin 1.3, there was something that was introduced, and it was Kotlin result. So Kotlin result is just kind of a wrapper for a value. That means that we can either have this value, and it's known as a success case, or we can have a failure, and that failure is represented by throwable. So as you can see, the result only has one type, only one generic. So we can only specify the type of returned value. We can specify the type of the error. So let's try to implement the function with more complex error handling using Kotlin result. So it looks like this. So what is good about it is that we do have an indication that something might go south because we are not returning just phone number. We are actually returning result of the phone number. And for all the cases, so for example, we check if the number is blank, then we can return a different exception, and then we can check if it matches the pattern, and we can return a different exception. For the success case, we just return the phone number wrapped into the result. So it looks okay. We can handle multiple cases. There is information about possibility of some kind of failure. So if we try to use it, it would look a little bit like that. Results also comes with all sorts of utility functions like on success, on failure, and so on. So as you can see, we can use that to access the wrapped value inside. So we can use on failure to actually handle the failure. And this is starting to get a little bit messy, so let's just focus on the failure. So what we have to do is to actually access the exception inside of the result and then do something with it. So we might do a when on the exception message in our case, because we use the same type of the exception. And then we can actually do something with it. So for our purpose, it's just printing. So are there any problems with that approach? So the first one is something that we mentioned before. So it's a pointless exception creation. We don't need that exception in that place because we are not even accessing the stack trace, and we know exactly when and where the exception happened. So we actually know how to handle it. And the second problem, I think it's even bigger one, is that this is not exhaustive. So because the error in Kotlin result is represented by the throwable, which is not a sealed interface, just regular interface, this will never be exhaustive. So now, if someone will change the implementation of this function, we won't know about it, and we might miss important error handling. So we can kind of see that the problems with Kotlin results actually are pretty much the same as with regular exceptions. There's one additional that Kotlin result brought to the table. So there's this function that is called run catching. So it is usually used on the edges of the system. And what it does is it catches all the exceptions that are from the invoke code and converts them wraps them into a result. So the problem with that is that it also catches cancellation exceptions. So if you are mixing result with the suspending functions, you can really shoot yourself in the foot. And I think there's not enough emphasis on that. There's not such a good documentation on that. So I would say that personally, I feel like Kotlin result introduced more confusion to the error handling because it not only didn't solve the problems that we actually had, it additionally created a new ones, and it somehow brought the exceptions back to the error handling, which we are not supposed to do in Kotlin. And this is pretty funny because I feel like we are using Kotlin result for error modeling a lot, and you can see that in the keep file of the Kotlin result, there is this paragraph. The result class is designed to capture generic failures of Kotlin functions for their later processing and should be used in general purpose API like features. The result class is not designed to represent domain-specific error conditions. So this is exactly what we shouldn't do, and we are doing frequently. So if using Kotlin result is not good an idea for handling the domain errors, what is? Actually, the keep file for the result is a good source of information for that, because in the next paragraph we can find this. So, in general, if some API requires its callers to handle failures locally, then it should use nullable types when these failures do not carry additional business meaning. So this is something that we already covered. For simple cases, using nullability is perfect. Or domain-specific data types to represent its successful results and failures. So it means that for handling domain errors in more complex scenarios, we should actually use our own type system, or our own types. So for that, we have a perfect tool in Kotlin, actually, because we have something that is called silt hierarchies. So, for example, we can use a silt interface to represent our errors. We can use enum, or we can use silt class. Everything works. But I would say one thing about Kotlin result, just going back quickly. I think the idea behind the Kotlin result was actually good, because we don't have a native way in Kotlin of returning two different types from a function. So we have to have some kind of wrapper. So in that term, the idea of Kotlin result was good. The only thing that actually spoils the party is the fact that we are representing failures, errors, as throwables, because it kind of defeats the purpose. And also, Kotlin result allowed us to do something that is called railway-oriented programming, which is a really cool concept that I don't want to get into too much, but there are a lot of resources on that in the internet. So what I actually am using for my error handling are not only the silt hierarchies, but I am actually implementing a custom result. So it is a little bit like Kotlin result, but it's a little bit similar to the Kotlin result, but not identical. And there are also some kind of libraries that are already implementing that, but actually implementation of that is really simple. I will show you in a minute. So if you want to use a library, you can use things like Arrow. There's even, I think, a library that is called Kotlin result, which is not Kotlin result. But yeah, there are some libraries that are ready for you if you want to use it. But actually implementing a custom one is not that hard. So let's start with the silt interface for the actual errors. So we can have something like that. This could be really an enum, but for sake of future-proofing, we are just implementing it as a silt interface. And the additional custom result is just this. So you can see that it kind of looks similar to Kotlin result. The only difference is that we actually have the type of the error. And this is really anything that we want to put there. So implementation of the function would look like this. We also have the multiple cases handled, but instead of creating the exceptions, we are actually just returning our objects. In terms of usage, we just use a when and handle that. And what you can see straight away is that there's actually no else clause. So this is actually exhaustive because we used the silt hierarchy for representing our error. So we can easily handle that. One thing that I would say about it is that it's getting a little bit verbose. But because we are just using silt interfaces, we can actually do some stuff to eradicate some of the boilerplate. So we can introduce some kind of common errors in our application. So let's say that we want to handle all the blank inputs in the application the same way, just displaying the dialog to the user or something like that. We can have a silt interface of the common errors, and then we can have some kind of handler for those common errors. So in terms of usage of that, it would actually be really simple, because instead of just declaring a blank number error for the phone validation, we can extend the common error. And what it brings to the table is that actually in our error handling, in the caller of the function, we can use the common error handler. And this is also completely type safe. So it allows us to cut a little bit down on the boilerplate of the solution. And actually this approach of using silt hierarchy with the custom result, in my mind, resolves most major problems with that we had with domain error handling. However, it's not perfect. It's not perfect because we do introduce a wrapper. We do have a lot of boilerplate still. So it also, if you would go down the route, because usually when you implement a custom result, you would also implement some kind of utility functions for that. So things like flap map, on success, on failure, similar to Kotlin result. And that kind of introduces a new style of programming that you have to get used to. So it's, again, not perfect. And I would say that, again, that domain error handling in Kotlin, I feel, is all over the place. And it really is resolved in some nice ways in different languages. So, for example, in Golang we can return multiple values from the function. So what we are doing for error handling is that we always return a value that we want to get and an error. And then we can actually, if there is no error, we can put a nil, so a null in Kotlin, for the error and actual value for the value. If there is an error, we return nil for the value, and then we return some kind of error. And so error handling of that function would look like it, and it's really simple. And what is nice is that it was introduced from the start of Golang. So this is a standard that actually everyone uses, and there is no confusion about it. So I think in that way, Kotlin is a little bit lacking, but good news are that the Kotlin team actually wants to address it. So starting with Kotlin 2.4, there are rich errors coming. What are rich errors? We will get like a new keyword error that we can actually add to our classes. And what it allows us to do is do kind of error union types. So you can see that our function now returns a phone number, but we have this new operator, and you have blank input error and invalid format error after that. So it means that, basically it means that the type that we return from that function can be either phone number, blank input error, or invalid format error. This is not like a fully fledged union types, because we can only do that with errors, with the error classes. But for errors, it's exactly that. So it follows a little bit of different type hierarchy. There's a new super type. It's any error, and error is actually implementing that, and phone number is also implementing that. So in terms of actual usage in our code base, it would look a little bit like that. So you can see that this is much nicer because we don't have that additional wrapping. We don't need to extract a wrapped value and deal with all that boilerplate. So this is really nice, and what is even nicer is that there will be a safe call and double bank available. So it means that it's kind of getting close to what we saw with the nullability. So we can use sort of the same syntax for both of those and just use it for different scenarios. And what I really hope is that we'll get a compiler check, so we cannot declare the function as having those errors unless we actually can return them. That would prevent us with ending up in the same way as we did with the checked exceptions. So to summarize, for domain error handling, for simple error scenarios, we should use nullability. And for complex error scenarios, we can use sealed hierarchies, and if you like it, you can use additionally the custom result. In my mind, when the rich errors will be available, this will supersede the sealed hierarchies plus custom result. So what about the other type of errors? So program logic failures. So the problem with those is that by their definition, we are not expecting those. These are usually result of our mistakes. So in terms of that, noticing this kind of error is as soon as possible is crucial. I'm sure you heard about how the catching the bug in the production is, I don't know, 1,000 times more costly than in the development. I don't remember the actual numbers, but one thing stands that we should catch those bugs and program logic failures as soon as possible. And how we can notice the errors faster? This is kind of counterintuitive, because I would say that we should introduce more failure points. So there is this paper that was released by NASA a long time ago, I think. This is called A Power of 10, and it actually includes all sorts of rules that they are following when developing their code base. And there are some stuff that is not really applicable anymore. Like, for example, there's a rule that the function should be longer than A4 paper when printed. So I don't think we should follow that, but there are also some useful rules. For example, we have a rule that says the assertion density of the code should average to a minimum of 2 assertions per function. Assertions are used to check for anomalous conditions that should never happen in real-life execution. What are assertions? We are really familiar with assertions from unit testing. But the assertions can be actually used in pretty much the same way in the production code. And it can, for example, verify if the input of the function is not something that we expected, or if the state of a variable is not something that we expected of in that moment of flow. So it kind of is something that adds more, like, can be used for checking if we are not in unwanted state in places where the compiler cannot actually check it for us. So for that reason, for that purpose, actually the exceptions are pretty much perfect. Why? Because they are crashing the program. And this is a really strong signal to us that actually something is not right. And again, for that, we can use some kind of inspiration from Kotlin standard library. So when we were talking about string conversion to integer, we had this function that is called toString or toInt or null. But we actually have the function that is called toInt. And this will actually crash your program if you use invalid input on that. So those two are really meant to be used on different scenarios. So the one that is safe, so the toInt or null, is meant to be used on the input that you actually don't control. This one can be used on the input that you control, and you want to assert that nothing is actually not as you expected. And we can, there are actually a couple of functions that in Kotlin that are used for such assertions. So we have the require function that checks for a Boolean condition, and if it doesn't match, it will actually throw illegal argument exception. So we can use that for checking our inputs. And there is also a check that is used to check for the state. And I know this might look scary, but honestly, the thing that is worse than having a crash when we are clicking a pay button is if nothing happens when you click the pay button. Why? Because if something crashes, we actually get a signal that something is not wrong. We get a crash in the Crashlytics. We get some kind of metrics that tell us that something is not all right. And if we actually get stuck in this place, it's worse because if you don't have very good metrics, you will actually need to wait for some kind of input from, for example, users that something is not right. And I know that depending on the domain, there might be some applications that can allow themselves to crash in the production. That's why you can actually implement those functions on your own, and you can, for example, crash always on the debug build type, and on the production you can actually just, for example, create a non-fatal and send it to Firebase. So the additional thing that it actually opens doors for is something that is called fast testing. Full disclaimer, I don't think it was ever implemented in Android because it's quite tricky to do, but it's just for like inspiration, and you can check it out. So fast testing is about getting our system and throwing as many invalid inputs and scenarios as we can, and we are checking if the system at some point will crash. And a very good example of fast testing is the company that is called Tiger Beetle. They are actually producing a transactional database And they are using the approach with the assertions combined with fast testing and simulation testing to the max. And it's really impressive what they are doing. They actually even developed a fully fledged video game that you can open in your browser, and you can actually interact with their system, and underneath there's a simulation going on. And you can, if the system crashes, that means that you found a bug using fast testing. Additional thing that I would like to mention is that using the exceptions and the assertions might actually allow you to catch the bugs faster, but it's not guaranteed that it will be actually reported. Like I said, that the crash is a pretty strong signal that something is not okay, but actually it happens that developers ignore the crashes even. Trust me, I saw that plenty of times. So what we can do is what I call screen of death. And this is kind of a tool that encourages developers to actually report the crash if they see one in the developments. So it's really a very simple piece of UI that when the crash happens, it just returns a stack trace. And you can copy it, send it. You could implement, I don't know, for example, creating a Jira bug or something like that from this piece of code, from this piece of UI. And we used that, and actually it was really effective of boosting our chance to spot the errors, because not only the developers could see it, but for example, QA engineers that might not be that familiar with the app, so they don't know if something that happened was a crash or something else. So that helped to report those. So as a summary, the first most important thing is to differentiate between different error types. So we have the domain errors that are unhappy paths, and then we have the program logic failures, which are actually a result of a programmer mistake. So for the domain errors, we should use the nulls to handle simple error cases. For the more complex ones, when we need multiple error cases, we can use sealed hierarchies, and we can add a little bit of sprinkle to that using custom result. And one thing that I didn't mention yet is that I know that in reality, we use a lot of libraries. We use a lot of legacy code that is throwing the exceptions all over the place. So what we have to actually do is to really guard the edges of our system and catch the exceptions there. Inside of the system, I wouldn't use exceptions for domain error modeling. For the program logic failures, we should actually use exceptions to spot and fix the bugs as soon as possible. I would say that don't be afraid to crash the program, especially in the debug. On the production, it depends on what your application actually does. But on debug, we should always crash the application if there is an unwanted state. And second of all, we can add tools to enable developers to easily report a bug. So that is for the main part. There's one additional bonus that I call. So it's about debugging native crashes. This is a very complex topic, and I'm also not an expert on that. But there's a new feature in Firebase that is really useful. So when a native crash happens, we actually, if it crashes on our device, we can access a tombstone file. This is like a huge, very confusing file that has all the information about the crash and the state of the native part of your application. And it actually looks very confusing, but for some cases it's very easy to interpret. Because in this case, I know that you cannot probably read it, but it just means that the reference table was overflown. So we are having too much references in our native code. So in some cases, this is really easy to interpret. And cool new feature in Firebase, starting from May this year, is that actually on Android 12, we'll get the tombstone files. So if you are having native crashes in your application, you can go to the Firebase and check if there are Android 12 devices reporting that. And using the tombstone files, you should be able to debug what actually happened. I also included the reference to the documentation on native crashes at the end. But for the main part, that is really it. Thank you very much for your attention. Yeah.